Okay, an inductor stores energy in a magnetic field. An inductor is basically a coil. That should be easy to remember because you probably remember making an electromagnet by wrapping wire around a nail. And so you made a magnet with a magnetic field with the coil of wire. Here you can see a schematic that shows you the coil of wire with the magnetic lines of force around it. And then several different forms of inductors. It can be a simple coil like this. It can be a coil wrapped on a toroidal form like this. This is an inductor that is adjustable. And what it has here is a coil that's been wrapped on a very rigid form. And it has a wiper on here that can, if you turn the coil, it will move up and down the coil like this. So it lets me tap where I want to tap on the coil by rotating the coil. It's a variable inductor. Here's another form of variable inductor. I have a coil here. It's fixed this time, but I have an iron rod that I can move in and out of that. And by moving that iron rod in and out of there, I can change the amount of inductance that I have. Another form of inductor is a transformer. Here I have a winding on an iron core. Here I have another winding on the same iron core. These two windings are sharing the magnetic flux that is in that iron core. The primary side, voltage is applied here. That's what produces the magnetic flux. The secondary side takes that magnetic flux, converts it to a voltage on the outside here. Okay, so this is a schematic of a drawing of how a transformer works. You have the primary, you have the secondary, and you have the magnetic flux connecting the two windings. Here's a picture of a form of transformer. And here are some schematic drawings of various transformers. This one has a small primary, number of windings in the primary, a big number of windings in the secondary. This would be a step-up transformer, so this would be lower voltage here, higher voltage here. Here it's just the opposite, a large number of windings in the primary, a small number in the secondary. This would be a step down, so I would have a high voltage here, low voltage here. Here is a transformer with multiple windings. I have the primary, and then I have several secondaries. So here I would have a lower voltage than the primary, lower voltage than the primary, and then close to, equal to, or larger than the voltage in the primary, depending on the number of turns. So those are some examples of inductors. A diode is an electrical component that allows current to flow in only one direction. A rectifier, and this is a little farther down the sheet if you're following there, a rectifier. I put it up here because these illustrate this so well. The diode only allows the current to flow in one direction. A rectifier is a diode that's being used to do exactly that, typically in a power supply. So if I'm looking at power supply here, and I have alternating current coming into my power supply, and it goes to the rectifier. Well, remember, the diode only lets the current flow one direction. So what I end up with, if I have just a simple diode rectifier, is a lump of voltage there, a lump of voltage there, a lump of voltage there. And it's direct current, isn't it, because it's all flowing in the same direction, but it's not very smooth. Okay, so I need my filter in my power supply to smooth that out into smooth direct current. If I use a full wave rectifier, I can flip this half here that I cut off with the half wave rectifier, I can flip it up the other direction here and get a full wave rectifier, and I get a much more efficient rectification, and I get something here that's much easier to filter into a smooth direct current. A transistor is a device that can use a current or a voltage signal to control current flow. This is a diagram for a transistor, and typically you'd be wanting to control a current flowing through the collector and emitter. You can control that by putting a voltage on the base of the transistor here. And depending on what kind of a voltage you have here, you can either block current from flowing, or you can allow a little bit of current to flow, or you can allow a full amount of the current that you have available to flow through your transistor. Okay? A bipolar transistor is made up of 3 layers of semiconducting material. and they have two junctions, 3 layers with 2 junctions between them like this. An NPN or a PNP. N-type semiconductor material on both sides with a P sandwiched in between, or the other way, P on both sides with an N-type sandwiched in between. What do transistors look like? Here are several different case styles for various purposes. The ones with the smaller cases and the plastic cases and so on are low power transistors that don't generate much heat. This one is a higher power transistor that would generate more heat. And this tab right here is used to get that heat out of the transistor, and so it doesn't burn itself up. This is a higher power transistor yet. These other 2 leads are on the back side of the case from what you're looking at here. And one of the leads is this case right here, which does a good job of transferring the heat energy out of the transistor and into a device called a heat sink that will carry it away from the transistor. Okay, a regulator controls the voltage from a power supply. Okay, what it does, it makes the voltage constant. Here's our power supply circuit again. Okay, and the regulator is this circuit right here, this resistor and this Zener diode is regulating that voltage so that it remains constant regardless of the load that's placed on the power supply. Okay, an LED, a light-emitting diode, can be used as a visual indicator. Here we have the light-emitting diode in this circuit, and that's your indicator light that your power supply is turned on. Okay, and we have a transformer that right here that's being used to raise or lower an alternating current voltage. Okay, so if we bring into this transformer an alternating current, okay, out of it will also come an alternating current at a different voltage. This rectifier right here, the rectifier diode, will chop off the negative going portions of that into this pulsating DC, and then the filter will smooth that out into direct current. And the voltage regulator here will keep the voltage of that direct current constant regardless of the load on it. Okay, a mixer can be used to change the frequency of a signal. Here we have a mixer circuit. They call it in the graphic, they call it a mixer or frequency changer. This is a radio receiver. We have a frequency coming in from the antenna going through a radio frequency amplifier. We want to change it to this frequency here so we can process it better. And to change it from this frequency to this frequency, we use a mixer that mixes a signal from a local oscillator to it, changes the frequency here, and then into the detector and the speaker. So a mixer is a circuit that can be used to change the frequency of a signal. Measuring voltages and currents in a circuit. When you measure voltage, you measure it parallel to the circuit. So here, with this voltmeter, I'm measuring the voltage of the battery in the circuit, right here. Okay? With this voltmeter here, I am measuring the voltage across this resistor. So I'm in parallel with the battery. I'm in parallel with the resistor. Now to measure the current, you remember current is the amount of electrons, the number of electrons moving through the circuit. In order to measure them, I have to make all the electrons go through the ammeter. So to do that, I have to break the circuit and put the ammeter in the circuit so that all the electrons have to go through it. And so I measure current in series with the circuit. A vertical antenna is perpendicular to the ground, like you see right here, vertical, perpendicular to the ground. A horizontal antenna is parallel to the ground. Okay, your horizontal antenna, your maximum radiation, is broadside to the antenna. Broadside to the antenna. Now, one thing I missed putting in this review is the beam antenna. Remember, it's possible we could have a question about a beam antenna. And a beam antenna is one that concentrates the signal in a particular direction. It takes the signal and focuses it in a particular direction, the beam antenna. Standing wave ratio is a measure of how well an antenna is matched to a transmission line, standing wave ratio. You want a perfect match to have the maximum transfer of power between your transmitter and your antenna. A properly stated SWR always has the larger number first, so it will always be stated as 4 to 1 or 2 to 1 or 1.2 to 1. The larger number will always be stated first. A perfect match is indicated by a 1-to-1 SWR reading. At an SWR mismatch of 2-to-1, most solid-state transmitters will start to reduce their power to protect themselves from damage. So when you get to that degree of mismatch in your system, the transmitter will begin to reduce power to save itself.